So first off, how many people here have ever played Kerbal Space Program?
Have or haven't?
Have. Okay. Yeah. Okay, so that's good because I'm not very good at this game and I'm going to embarrass myself. So hopefully, however, I will not crash any Kerbal Space Program. Alright, maybe I'll just try to hold it up here until I have to actually get to the game. So we're going to start out at the kind of beginning of the space race where we're sending humans into space. So this is a recreation of the Vostok 1 spacecraft, which launched Yuri Gagarin into space. And I want to say also that I did not make these models. These were actually taken online from someone called Admiral Andre, who has a YouTube video. So if you're interested in Kerbal Space Program and want to know more how to build these models, I suggest that you go check out his YouTube page. So this is the Vostok 1 model, and we have our Kerbin astronaut down here, Jebediah Kerbin, and he's about to launch into space and become the first Kerbin to actually go into space. So we're going to go ahead and turn our engines full blast and launch them off. This rocket was modeled after a missile called the R-7 ICBM. So the space race really was built on top of military technology. The first versions of the Soviet spacecraft, Sputnik, Vostok, they were all built around this R-7 missile. So they all looked pretty much the same. The only difference you might notice when you look at them is that maybe these stages up here look a bit smaller or larger depending on where this thing is going into space. But for the most part, they all have this iconic, these 4 boosters that you can see down here. These are the liquid boosters that got them into space. Today, we generally use solid rocket boosters as your first stage, and then you go to liquid, so you can kind of adjust how much thrust you're putting into your rocket, but at this point, we didn't really have very good solid rocket boosters, so everything was liquid. Also, at this point, we're going to start to turn our spacecraft. So in space, you don't want to just... Oh, we're turning too much here. I told you I'm not very good at this game. Right? Alright, we're going to hold it there. That's what it works. So, you don't want to just go straight up in space, because if you do, then you're going to do kind of what we did for our first Mercury program for Freedom 7, which was Alan Shepard. You're just going to go straight up and you're going to come straight back down. So Gagarin, he did not do that. He actually went into a full orbit around the Earth. At this point, our boosters had depleted themselves, so you can kick those off. It's a pretty big explosion, so it's going to kick our rocket around. It's going to come back, don't worry. Maybe we should start worrying. So one of the things that the Soviets were really worried about, as you can probably tell, is that they didn't know if this was going to work. In fact, when they looked at the success rate of their rockets, they were 50%. They launched about 24 of these rockets. 50% of these had actually survived, didn't blow up. And so when Gagarin first went into space, Sergei Korolev, who was the head of the space program, was so nervous he couldn't sleep. They tried giving him drugs to help him calm down. It didn't work. Gagarin was originally on a pre-programmed flight. So the Soviets sent all the programs into the spacecraft ahead of time, and then, if anything went wrong, then Gagarin was to control the spacecraft. So they didn't want him to touch anything. We're going to crash soon. We're just going to cut out our engines here so we don't speak to our death. I've got multiple saves logged in here because I anticipated this occurring, so we're still in good shape. So one of the things that, if something goes wrong, you have to be able to change it. If you're on a fully automatic course, of course, you're not going to be able to do that. So they had in an envelope the code to unlock the computer just in case something went wrong. And then as they're taking him to the launch pad, they secretly told him the code anyway, because they didn't really want to risk anything happening with him. So let's pretend that that didn't quite happen, and we're going to go successfully up into space here. So Gagarin, as opposed to Shepard again, did one full orbit around the Earth. So in this case here, we've launched into orbits, everything went fine, we ejected all of our outer stages, and now we just have our spacecraft. This is our little, thank you. This is our orbital capsule here where Gagarin is. This is his engine. He's got all of our antennas deployed, so he has successfully made it into space, and he's doing this one full orbit around the Earth. If you look at the map of his trajectory, you can see here this is his capsule, and this is where he's going around the Earth. So he wants to, of course, make it back to Russia. So we have to send him back home. So a little bit of orbital mechanics here. If you want to send a spacecraft back to Earth to land, it's not like a plane. You don't just point the nose of the craft at the ground and turn on your engine, because you're not really flying. You're actually in orbit, and that's a very subtle but significant difference. If you want to get back home, if you want to get back to Earth, you have to decrease your orbit. This little circle here, which is this orbit, has to decrease and come back down to Earth. So we're going to do that here. I'm going to point the spacecraft retrograde. So the spacecraft is now pointing opposite the direction of motion. And if I burn my engines in this direction, then our orbit will start to decrease. You can see that line has already started to shorten. As we burn, it's getting closer and closer to Earth. And if we burn it long enough, eventually it is going to actually hit Earth, and we will then be on a re-entry corridor. So at this point then, we burned enough that our rocket is on its way back to Earth, so we can decouple our little probe here from our engine. And we can retract our antennas. We're not going to need those anymore. And he's on his way back home. So let's go ahead and speed this up until he gets into the atmosphere. One of the troubles about the Vostok capsules was that it was round. So you look at the Apollo spacecraft and the Gemini spacecraft, they all look kind of cylinder. They're like a cylinder, and then they got this kind of flat wedge bottom. That's mostly for aerodynamic purposes to help dissipate your heat. If you send this capsule down, it's going to wobble like crazy. And Gagarin actually underwent about 10 Gs as he was coming down to the Earth because this thing was just spinning rapidly. In typical Soviet fashion, of course, you don't tell anybody about that. You just hope everything works out. But he was, of course, able to make it back to Earth safely. So let's speed this up a bit. And I'll try not to kill him this time. So you can see it's already starting to wobble around. Once you start getting to the upwards of the atmosphere, you'll start to see the heat. You'll start to see kind of flames showing up around the outside of the ship. And it's going pretty crazy. If we slow this down and actually look inside the spacecraft, and you can see his little view here. He's got flames going outside the spacecraft. That's okay. That's supposed to happen. Gagarin's not worried. He's a tough guy. And during this period, you can't communicate with the Earth. You're in what's called a blackout period as you head into the ionosphere. So there's a few minutes there where you don't really know what's happening. If you're on the ground trying to talk to your astronaut, you don't know if they're alive, if they made it or not. You gotta wait till you can get visual confirmation of the actual spacecraft. So with Vostok 1, what was different about the Russian program at this stage with the American program was they did have parachutes. This would parachute down to land on the Earth, but it was coming down still at a very, very fast rate. So the rate that was coming down was still pretty dangerous to the cosmonaut inside. So what they did instead was they actually ejected. So this is our little cosmonaut right there, and he has his own little parachute. So Gagarin, when he was landing, he ejected from his capsule. He didn't. The parachute of the capsule didn't take him down. He ejected and had his own parachute that took him down to the surface of the Earth, back to Russia. He was also a bit off course. So earlier, we separated our module from the engine, and there was a nice clean separation. They both went their own separate ways. That didn't happen for Gagarin. It actually stayed attached due to some communication cables that tangled it up, and so that threw off the entire center of mass of the whole craft. So they came in off course. He landed near some school children. They freaked out, and some guy just flew out from the sky, got into some giant capsule. But he told them, don't worry, I'm a citizen of the Soviet Union. I come in peace. Please get me a phone so I can talk to Moscow and tell them that. And so he eventually made it back home. And the way the program works, just you have to get down to some certain altitude before the thing inflates. but I guarantee you this time he's gonna survive. So, congratulations to Gagarin. He made it back to Earth. And that was pretty impressive considering that, you gotta get into a rocket that's got a 50% success rate, which has a 50% failure rate. And that's pretty damn high, and I don't know if I can do it. Alright. So let's move on then to the next space program, which was the Voskhod 2 program. So this was kind of the next step for the Soviet Union. They got the Voskhod program that went up into space, that's great and all, but let's do something that's a little bit more exciting. So at this point, we have just separated our craft from the third stage rocket that took us up into the atmosphere. And now we're going to do something that's never been done before. We're going to do a spacewalk. So in this capsule is the brave Alexei Leonov. We're going to inflate our airlock, and we're going to transfer one of our Kerbonauts inside and have them do an EVA. Again, there were problems with this. This is an inflatable airlock. It just pops out of the spacecraft. Cosmonaut goes inside, wait for the whole thing to pressurize, and you close the door, and then you do your little EVA. And at this point, you kind of walked around for about 10 minutes outside the spacecraft. We don't actually have tethers in Kerbal Space Program, and if I let go, there's a 90% chance we're not getting back in, so we're just gonna leave them right there. So for 10 minutes then, Leonov was outside the capsule on his spacewalk. And you notice that there are problems right away, because when you go into space, you gotta have a pressurized suit, and that suit just completely inflated and became completely rigid. So he had a video camera on his chest that he was supposed to activate by pressing a button on his leg. He couldn't actually reach it because the suit was so rigid. So the only images that we have of the spacewalk is from inside the capsule or from the camera that was like right outside the capsule. We don't have any from him, like from the one that was on his chest. So after 10 minutes then, he has to go back in, but his suit is so inflated that he has to go in head first as opposed to feet first like he was supposed to. And then he has to get back in from this airlock into the capsule. And as Christian was saying, he couldn't get in there because his suit was too big. So he had to bleed out his oxygen to get back inside. So you gotta really give it to these early cosmonauts because they were taking incredible risks to go into space and to do things that had never been done before. So we're gonna go ahead and transfer our cosmonaut back to the module here. And now everything's back in. They ran into the same problem that Gagarin did. When they tried to go back into orbit, this module here would not completely decouple. So they were still attached as they're coming into the atmosphere, and again, that throws you off center, it throws you off target. Eventually, as you go closer and closer to Earth, those cables that are connecting those two craft are going to burn away, and you'll eventually be able to land. But they landed not near a school, unfortunately, they landed in the middle of the forest. And it was winter, it was freezing cold, about minus 20 degrees, it was mating time with the wolves, which was really bad situation to be in. And so from this experience, they decided to make a few modifications. Now in this capsule, these two cosmonauts had a pistol. In case they did go off course, something happened, they had to fend off the wilderness, or maybe they landed in the unfriendly area of the US and they had to fight off the US citizens or something, the US government. But they realized that a pistol is not really going to do a whole lot against a giant wolf or a bear or a moose or any of the other things that live inside a forest. So they came up with this other new complicated gun, which was a pistol, a shotgun, and a machete all combined into one. And so the Russians would take this on their trips. I think that up until even the space shuttle, they were carrying weapons into space, just in case things went wrong. And we got it pretty cushy in the US. Like, if you land off course, you're gonna land like maybe in Georgia or Mississippi, which maybe is the same as landing on some Air Force, I don't know. But they're gonna land in the water, so we didn't really have to worry about guns, thankfully. So we did not have the same problems that they did here. So as Christian was saying, this is also kind of the zenith, the peak of the Soviet space program. Everything from here kind of just went straight downhill. They didn't really have much success. They had a few more Vostok programs, which were marginally successful. But you can tell just by looking at the spacecraft, this looks almost exactly the same as the Vostok spacecraft. There's really not much difference there. And if you want to do something better, you need a better spacecraft. But their Soyuz craft wasn't up to the challenge. It killed Komarov, who was one of the first person to die in space from a space-related accident. So they ran into a lot of troubles. They also had a unique moon program. They wanted to go to the moon as well. But again, in Soviet fashion, you don't tell anyone that you're going to go to the moon because if you fail, that means you know up your failures. So in secret, they had something called the N1L3 complex. And this would be the companion to the Apollo program. This would be like our Saturn V, which would take astronauts to the moon and land. They had two programs. One of these was this moon lander, the other was a circumlunar flight, which Christian mentioned, the Zone program. That would take you around the moon. This one would take you to the moon and land on it. They even had their own version of a lunar lander, which they never got to work properly. But they did get to test some of these rockets. And so this is our N1 rocket right here. We're going to test this out real quick. And it's a gigantic rocket. It's got more power than the Saturn V does. But unfortunately, as compared to the Saturn V, it's not as well engineered. And seconds into liftoff, the engines cut out and it fell back to the launch pad. And that's not what you want to have happen. Now, thankfully, there was nobody inside. They knew that this thing, didn't have the best chance of success. But the explosion was so great that it actually obliterated the launch pad. They couldn't use it again because it was so explosive. It was, if not the largest, one of the largest non-nuclear explosions in the history of Earth. So there goes kind of their whole moon program. Zonds could get you around the Earth, but you couldn't put humans on it. They did land the tortoises, but the tortoises underwent such gigantic G-forces that if humans were in there, they would have died. This thing obviously blew up in the launch pad, so they're kind of screwed at this point, and they don't really have much else to throw at the US, so we finally then get to Apollo. So I'm going to skip over the Gemini program just because Gemini is it's very similar to the Vostok and Vostok programs where you're doing these things like docking or rendezvous. So instead, we're just going to go straight to the rocket to take us into orbit. We've docked with our lunar module here. This is the service module, this is the lunar module. They are docked together. And we can pull out our module here. Let's decouple that. And so at this point, we now have the tools to go to the moon. And if you look at the orbit that we're on, we are in what's called a free trajectory, a free return orbit. So these lines here represent the orbit that we're going to be taking. And so this line right here that shows our current trajectory, we're going to wrap around the moon in figure 8, and then it would sling us back to Kerbal or to the Earth. Kerbal Space Program is kind of optimistic, and they show this path going through the Earth. So I guess if you did manage to actually punch a hole through the Earth, that's where you land. But we would really just kind of land somewhere in the ocean. Hopefully not crash that time. So let's go to the moon. So I'm going to speed up this process because otherwise we'd be here for 3 hours. We don't want to be here for 3 hours right for this. So once you get to the moon, you again have to slow down and be captured by the moon's gravity. So we have to do the same thing that we did when we took Gagarin back to Earth. We have to slow down our orbit. So at this point here, this is our apophis. I'm probably pronouncing that wrong. That's kind of the furthest away we are from the moon. Sorry, we want the periapsis right there. At this point, you add a maneuver and you kill your velocity. So we're going to highlight this arrow here. You can see our orbit now is wrapping back towards around the moon. So we're going to go ahead and speed things up. We're going to point our craft in the direction of the maneuver. And then this is going to be called a trans-moon injection. So we just did a trans-lunar injection, which is the orbit that took us to go around the moon on that free trajectory. But now you want to actually land on the moon. So the previous Apollo programs, 10, I guess it is just 10 and 11, they use this free return trajectory. Apollos 13, 12, and beyond, they use a modified version of this because they wanted to land somewhere else on the moon. And if you just do this translunar ejection, this free return, you're pretty limited by where you can land. So the problem with Apollo 13, why couldn't they just kind of sit around and be flung around by the moon to come back to Earth, is because they had already made a course correction. They made this course correction to land somewhere on the lunar highlands, and at that point, you were then off of this free return trajectory. And so the big thing is, how do you actually get the astronauts back home? You have to do a lot of very careful maneuvering to get to that point. At this point, though, we're still on our free return trajectory, so we have to change that. We have to actually burn near the moon to slow ourselves down and allow ourselves to be captured by the moon. And if you can see here, this is our burn time, 43 seconds. You don't have to do much. So you don't have to burn your engine for very long because the moon's gravity really isn't that big compared to the Earth's. We're almost there. Alright. So we're ready for our injection here. So we're going to go ahead and just burn our engine's full blast. You can see the orbit kind of come around, just swing around the moon, and eventually it's going to take us into. This is a pretty elliptical orbit, but you know what? It's close enough. We can still land in here. What's that turn? What's wrong with me? There we go. Alright, so now we're on track. Now we're going to land. You can see our orbit is wrapping around the moon. So we're going to say that's pretty good right there. When they did this, they were on the dark side of the moon. So they couldn't communicate with the Earth, so Earth didn't really know what Apollo was doing or where they were, because you had to do this in kind of blackout conditions, so you couldn't talk to Houston and get any kind of course corrections. You burn this engine on, and once you come around and start talking to Houston, you hope that you are in the correct position, and you can then land on the moon. So at this point, we're pretty good. So I did make a mistake here that I only had 2 astronauts. We're supposed to have 3, Michael Collins, Neil Armstrong, and Buzz Aldrin. So we're just going to transfer over one of our astronauts here. And they are going to go into the lunar module, and they're going to actually do the moon landing. So to do that, you have to undock. And so we are now on our way to the moon. Again, you want to turn your spacecraft towards retrograde so that you can actually land on the moon, burn your engines so that you can decay your orbit so that you're going to be able to land. I'm going to go ahead and extend the ladders here. So I'll be honest, I never do Twitch streaming, but I'm starting to understand all the pressure that's kind of under you sometimes when you're like being watched by all those people. Like, God, don't listen to this. Alright, so let's go ahead and burn our engine. There you go. And you can see our orbit has decayed, and we are going to land on the moon. So we're going to speed this up a bit. So again, this is honestly the part that I had the hardest trouble with, so there is a very good chance that we're going to crash. But that's okay, because they knew what they're in for when they signed up for this, right? They knew that there was a chance they were not going to hit that. So as the actual astronauts were on their way towards the moon, they started getting these alarms on their computer, 1202 and 1201 alarms. So has anybody heard of that? I don't know how popular that is in pop culture, but this is actually like a pretty significant alarm that they didn't really know about. The astronauts inside had no idea what was going on. They just knew that there was this alarm. They communicated back to Houston to let them know, And it turns out that the computer on board was just being overloaded with radar information. So this thing is being overloaded with information, it can't take on new tasks, so it has to kind of prioritize what is going to be kind of fitted into its memory slots. So every time you got this alarm, the software had to do a reset. So you get this alarm, it resets, reloads all of its programs, reprioritizes everything, and then kind of continues on. The trouble is, if you got these alarms in quick succession, that means that this computer is constantly rebooting, and you can lose all of your telemetry data. If that happened, then they would have had to do an abort and go back up to the service module, go back home. But weeks before the actual Apollo 11 launch, they were running simulations. And the flight control group, like Gene Kranz and his whole commanders and engineers, ran into this exact alarm. And they didn't know what it was either. And so when they got this alarm, they said, well, shoot, we're going off course, abort. And so they aborted the mission. And afterwards, they kind of got chewed out. This is not an abortable program. We still can land on the moon. All it means is the computer's a bit overloaded, but everything's still going okay. If they had not done that, if they had not learned what that alarm meant, then they would have aborted. They would have had to go back to the service module, and God knows what that would have done for the Apollo program when your first launch is a failure, and then you learned out that it wasn't even a necessary failure, that you still could have continued on. So thankfully, we did not have that issue because they did their practice, they did their homework, and so they knew what exactly was going on. So this is taking a bit of time. We're going to try to speed things up here. Hopefully not too much. So up here you can see this is our altitude above the moon. This is our speed. So we're going pretty fast here. So now we're going to start to kill our speed a bit more. And again, the way you want to do this is really nice and slowly and carefully, but we don't have time for that, right? We're trying to beat the Soviets. We got to speed everything up. So we gotta be a little risky here to get down to the moon. As the craft was coming down, getting close to the surface, Neil Armstrong had noticed that it was trying to take them into a rough patch of boulders. So the programmed landing area then had to be changed. So he had to actually take manual control of the spacecraft, move it around to try to find a place to land. And even when he was moving it around, he was still finding craters, he was still finding places that weren't really good places to land. So if you listen to the actual transcript, the actual radio signal of Apollo 11, you can hear these calls from Houston saying like 60 seconds, 30 seconds. That means you have about 60 seconds of fuel left until you have to make a go, no-go decision. So once you hit that call, I believe it's called the bingo call, that means you only have 30 seconds to land or to abort, and so at the end of that, you better make a decision of where you're going. So they were getting pretty close. They had hit the 30-second mark by the time they actually landed on the moon, which meant that they had about a minute or so of fuel left in their spacecraft. So it's not as dire as it might seem. You still had about a minute left. You still could get back to the service module if you had to. But still definitely not exactly what you wanted to do. And I don't know if anybody saw the Apollo 11 movie. It's like the documentary about the Apollo 11 launch. They showed Neil Armstrong's heart rate before, like when the computer was taking over, and then when he took over, it went from about like 100 to 150. So he was under a lot of stress, of course, trying to land this thing and not crash, which is pretty understandable. All right, so we're getting a little bit closer now. Still taking a bit of time. Let's try to speed this up a little bit more. So one thing that is not on the spacecraft are those that contact light that Jacob was talking about in trivia. So those were little kind of antennas that jutted out from the landing feet, not too far, like maybe about 6 inches to a foot, and they would tell you once they hit the ground, there would be a light in the canvas that would light up. So when we say that contact light was the first word spoken from the surface of the moon, it's because at that point the module was in contact with the moon, and so therefore you are technically on the moon. And so those words then were contact light. Buzz Aldrin is very adamant that he was the first one to speak the first words on the moon. If you read into it at all, Buzz Aldrin is very upset that he was not the first person on the moon, and so this is kind of, I think, his consolation. All right, so we were getting closer. The trouble with this is if you start burning your engines too much, then you actually start to push away from the moon. So you have to be very careful in how much thrust you're putting out to land successfully on the moon so that you're not just pushing yourself straight up. And that's an issue that I've run into a lot, and I think we're gonna be okay here. This is our little shadow down there. We're coming in a bit fast, about 30 meters a second. Ideally, you want to be around under 10 meters a second to land successfully. At this point, I think we're in pretty good shape. This is tense, so you can feel the tension, right? This is what Neil Armstrong must have felt like, I'm sure. I can feel it. It's not that hard, right? About 180 right now. Alright, the unfortunate thing is we're at a bit of a slope. That might be a bit of a problem, but I think we're gonna be okay. So we're coming in 5 meters a second. Let's speed this up. Let's go. Oh shit, I bounced off again. We're going back, Alright, we made it, thank God. Alright. Thank you. Alright, so we're at a bit of an angle here, but whatever. We made it to the moon, that's all that matters. Let's turn off this
We made it.
thing. And we made it, so of course you gotta do an EVA. You gotta jump out. We're gonna have our Kerbal do a little spacewalk here. They move pretty good. They're Kerbals. We don't need ladders where we're going. Alright, and since you're on the moon, one of the things that you gotta do, of course, is plant the flag. So we're gonna go ahead and plant our Kerbal Space Program flag right there on the moon. We did it. Screw the Russians, the US won. Alright, so if you wanted to be completely accurate, then you'd want to go back into this module. This half here actually blasts off and is going to redock with the service module up in space, and then that would carry you back home. I am not that good at Kerbal Space Program to do anything close to that, so I think this is a good point to end here. Eventually, as they would dock up with the lander up in space, they would make their way all the way back home. Just like you saw before, you gotta come into the atmosphere, deploy your parachutes, then they landed successfully in the ocean, picked up by the Navy. So everything went pretty well, and we made it to the moon, and we went back several more times. But this is, a very rough idea of what they had to do to actually get there. So thank you, and I can take any questions.
How hard did the actual astronauts?
How hard did the actual astronauts land? Ooh, that's a good question. They were going pretty slow. I think they were at like under a meter a second. One of the later missions landed hard enough that the engine bell on this stage here actually kind of crumbled, but it was designed to do that. So they came down pretty hard, but they were still okay. Everything was designed pretty tough to withstand this kind of effects.
So from ground wanted to do a Earth rendezvous. How would that work?
In Earth rendezvous, I guess I'm not actually sure what that would entail. Is that where you just, instead of the figure eight, you just kind of go straight from Earth to the moon?
Yeah. So, you're asking about the Earth rendezvous?
Right.
Yeah. So basically, that was focused on. It was more about building the spacecraft around Earth orbit. So instead of launching the entire command and lunar module together, you would launch several pieces and assemble that in Earth orbit. And then once you have a spacecraft, and then you refuel it. And once you have that, then you go.
So what would go to the moon?
It would be a same lunar module, command module, but it's just that you wouldn't have to lift that off all at once.
You wouldn't have the stages, the stages of the Saturn V to get up there. You just have the service module and the lunar module to go out to the moon. And that was all that we needed to really come back. It's just that service module.
What equipment is on the moon right now?
So they got a few. Yeah. So what was left on the moon? What is the scientific equipment? So on Apollo 11, they put down, I believe, 3 instruments. One was a seismometer, one was retroreflectors, so you can shoot a laser up at the moon, it bounces off and comes back at you at Earth. And then they also had solar wind experiments. So I believe the seismometers are still going. The retroreflector doesn't require any power, so we're still actually using that today, sending lasers up to the moon and measuring how long it takes for the light to come back. And then a lot of the other stuff was just like taking stuff back from the moon, taking moon rocks, taking moon soil. I'm not sure what other things were left on the moon.
So you did now, you used the method of assembling a craft on the Kerbal orbit first? Does that mean you would not have needed the Saturn rocket?
So the question is, if you assembled it in Earth orbit first, would you not need the Saturn V? And that's my understanding, is that Saturn V takes you from the ground, puts you into Earth orbit, so at that point, you're circling around the Earth, and then I think third stage of that rocket is the one that actually puts you into this translunar injection. So you would need at least a very smaller rocket. You wouldn't need the massive Saturn V.
I don't have a question, more a statement. So I know you were pretty nervous about doing this landing in front of people. I just wanted to let you know that. So before each talk, we take a picture of the speaker and tweet it out. The official Kerbal Space Program Twitter replied to our tweet and said, "That's amazing," in that animation. So thought that might make you feel better.